Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to a Godot tutorial. It has been a little while since I've done my last tutorial video, and sometimes it feels like the longer you go without making one, the harder it is to make one, so we're just making one today. Let's do this. So we're going to be doing a top-down movement example for Godot, and this is what it will look like in the end. Let me maximize it. Well, maximizing it doesn't really help since we don't have a view, but you can see I've got a character moving around on the screen. The movement is pretty fluid, and the character will slide along walls. Now this isn't anything too special, nothing too complicated to do, but it would be a good start if you wanted to make like a top-down shooter with zombies or something like that, because it's got nice movement and working collisions. So let's start it. I'm using Godot 3.1 .1 stable. So we will click new project here. We're going to come to this folder and we'll call this top down movement, like that. And we need to create folder and then create and edit. So we're in Godot here. This is kind of a beginner tutorial, but I'm not going to explain in depth different areas of programming. Just kind of cover it as we go. So first we need to create a new scene. I'm going to add a custom node and just do a node like this. We'll call this world. And we're going to switch to our 2D view. Now we're going to create a player, and this player will be a kinematic body. So kinematic body nodes, and to do that we can just add a new node, search kinematic, and we've got a kinematic body 2D. These nodes are used for creating characters that you want to be able to interact with solid objects in the room, to collide with them, but you want to be able to manipulate their physics manually in code, and kind of fine-tune them. So platform characters, stuff like that. It's a pretty common node to use. We'll name this one player. And we're actually going to make this its own scene, which just means it will be kind of its own little object in the room. So we're going to right click and do save branch as scene. Save. We're also going to save our world scene. We can just do Control S in order to do that. Save. And it usually names the scene after the node. So once we've done that, you'll see this little scene icon appear right here. We can click on that and it will actually open up a new tab for our player scene. And if we click on that, you can see all we've got is the player here. So click on the tab for our player scene and we're going to add a sprite node. So click add node and sprite. We're going to just drag the icon, the Godot icon, classic. We'll be using it. And we're going to add a collision as well. If you can see, there's a little error message or warning message here saying that this node doesn't have a shape, and so it can't collide with any objects. So we need to give it a shape. So let's add a collision shape node. So we can do collision shape 2D, and I'm just going to rename this collider. And we'll come to our shapes and we'll do a new circle shape. So once you click on a node over here on the right, you'll be able to see the properties of that node. And we need to give it an actual shape, this collider. So let's click on the empty and we'll do new circle shape 2D. And once we've done that, we can click on the circle shape and it will give us information about it. And we're going to give it a radius of 32. There we go. So we've got a nice circle collider for our character, like that. We'll save. If we come back we'll save with Control S. If we come back to our world scene here, we can actually select the player and place them somewhere in the room. But make sure you do that in the world scene and not in the player scene. In the player scene, we want to leave it just the way it is. Okay. Now let's add some motion to our character. So we're going to click on our player. Well, just come into here, click on the player, and attach a new script with this icon right here. Then it should just save it as player.gd automatically. We can create this new script, and it will open up into the script area. So inside of here, we want to create some variables. So we'll create a variable called max speed, and I'm going to set this equal to 500, and we're going to do an acceleration. I'm going to set this equal to 2000. Now, why is my acceleration so much faster than my max speed? Well, with the kinematic body, we're going to use a function called move and slide, and it automatically applies a delta value to the motion that you pass into it, which is great. But when we're accelerating and decelerating, we need to apply delta to that as well, so that our acceleration and deceleration look smooth with the frame rate of our game. And so it automatically applies delta to the motion in the function, but we have to manually apply delta to our acceleration and deceleration. And so this number is huge right now, but once we apply delta to it, it will get quite a bit smaller because the delta value is really low. Then we're going to create another variable, and this one will be called motion. And we're going to set it equal to vector 2. And so a vector 2 is just an x and a y value that will represent our motion on the Cartesian plane. So we'll be traveling either x positive, x negative, y positive, y negative, and those two values combined will create a 360-degree motion for our character. So once we've done that, we can come into here and we can well, let's create a few functions here. So we're going to create a function called getAxis. Okay? And we'll just call pass right now. And we'll create another one called applyFriction. And it's going to take an amount. We'll just pass for now. And another one called applyMovement. And it's going to take an amount as well. And we'll just pass for now on that. So we've got these three functions. We're going to be using them inside of a built-in function. This function is called physics process. So this function is run every single physics frame of the game, or it's updated on the physics frame. I'm fairly certain. So it's run every single physics frame of the game, and we can use this to move our player around. So the first thing we're going to want to do is get our axis. So var axis equals get axis. Okay, so we're calling our get axis function right here, which currently doesn't do anything, but it's going to, and let's actually rename it. Let's call this get input axis. Get input axis. So this is going to be getting our input and converting it into an axis value. That way we can easily use that to determine which direction we're heading. So once we've done that, we're going to say if axis equals vector2.0. Then we're going to apply the friction. And our amount is going to be acceleration times delta. Else, apply the movement, and the amount is going to be axis times acceleration times delta, like that. And finally, we need to actually move our character. So we'll have motion equals move and slide motion. So let's talk about this a little bit, this logic. So we're going to say if our axis is equal to 0, vector 2, 0. That's a vector that just has 0 for the x value and 0 for the y value. It's basically the origin. So if our axis is at its origin, centered, then we're going to apply friction. If not, then we want to apply movement. So we can use this to determine whether or not we are getting some sort of input from the player. Now you can imagine that this axis is like an analog stick on a controller, right? And when the analog stick is at its resting position in the very center, that would be vector 2, 0, 0, like this. But if you press the analog stick into a direction, then it would create some sort of a value depending on the direction that you pressed on your analog stick. And so we apply the friction when they're not moving. If they are moving, we apply that force, the movement force. Now the move and slide function is built into Godot, and it will just attempt to move. It's built into the kinematic body. It will attempt to move a kinematic body, and if it runs into a wall or something, it will attempt to slide along that wall. And this function returns whatever motion was left over. So that's why we're setting our motion variable equal to whatever was left over. That allows us to continue sliding. It allows us to remember the previous motion after the collision, basically whatever was left over after the collision. Okay, so one other thing I want to mention here is that you can easily hold control and click on a function like move and slide, and you will get the documentation for it. Or you can search the help and just type in kinematic body like this, and you can see all of the functions that it has, who it inherits from, and the documentation is very nice that way. The physics process here, we could also see, if we click on it, it's under the node, called during the physics process step of the main loop. Physics process means that the frame rate is synced to the physics. So that's what it is, it's synced to the physics. And it says the delta variable should be constant because of the physics. So once we've done this, we can then fill in these functions that we created earlier. So how are we going to get the axis? The axes. So we're going to create a variable, and we'll set it just equal to vector 2.0, like this. So that'll give us a, actually let's do this one up here, .0 as well, .0. So we got a zeroed out vector. Then we're going to get the x value for this. So var axis dot x equals int. Well, let's just do this. Input dot is action pressed UI right minus input dot is action pressed UI left. Okay, this is something that I would do in GameMaker a lot of the time, which is a very common thing. I think Sean Spalding kind of popularized it with his videos, but you will get whether or not they're pressing the right key, and if they are, this would return 1. And then whether or not they're pressing the left key. Let's say they are pressing the right key, but they're not pressing the left key. Then we get 1 minus 0, which would just be 1. And that would be, our x value would be 1, so positive 1. If they're not pressing the right key and they are pressing the left key, this would be 0, this would be 1, so then we'd be negative 1, which would be to the left. Negative 1, an axis of negative 1 would be to the left. So it's a really clever trick. However, we've got a problem. Oh, first of all, we need to remove the var statement there because we've already declared that variable up here. So we don't need to redeclare it. But the problem is that these values return a bool, which is true or false. We need to convert them to an int, which would then give us a 0 or a 1. So we just type int parentheses and then add our ending parentheses here to encapsulate this function. And then we'll do another one right here, int, and end it here to encapsulate this bit here, to call it on this. So we're going to do the same thing but with the y value. Exist.y equals int input.is action pressed. And for this we're going to do down first. And then up. Just like that. So we've set the axes. Now we want to normalize this vector. And what that basically means is, let me show you here real quick. If we open up paint.net, let's say we have our vector right here. Here's our, that was not a very straight line. Here's our Cartesian plane. I can't pronounce that right now. Okay. So let's say we've got our point 1, 1 right here. That vector right here, this vector, would have a length of greater than 1. Because you can see if it was actually 1, it would be around this circle like this and somewhere around here. So its length is greater than 1. However, let's say we had just a vector of 1 in the x. So this right here would be 1 in the x and technically negative 1 in the y, right? This one down here, let's say it is 1 in the x and 0 in the y. This one right here would have a length of 1, okay? So if you normalize a vector, what it does is it makes its length 1. No matter which direction it's pointing or how long it is, it always just cuts it off right at this circle and makes its length 1. And this is a very, very scribbly drawing, but that gives you the general idea of what we're doing here. So we can say return axes dot normalized, and this function right here will just give it a length of 1. And that's beneficial. That way we don't move faster at diagonals than we do at the cardinal directions. If you remember, a lot of times when you're making a game, that's a problem that needs to be solved. And a lot of older games, they would actually just leave it. So you would just move faster in diagonals than you would at the cardinal direction. So this fixes that for us. And then we return that value back out. So our get input function is now working. So let's apply friction. So here's how we're going to do the friction. We're going to say if motion dot length is greater than the amount, so the amount of friction that we want to apply, then we'll say motion minus equals motion dot normalized times amount. So we're taking our current motion and then we're normalizing that same motion and we're adding, or we're multiplying it by the amount. So let's say our friction amount is 10, for example. Then this vector is going to have a length of 10. So if we come back into here, let's say, don't save. Let's say we're headed in this direction and our vector length is 100, okay? So what we're going to do is we're going to subtract this same vector. So let's take that same vector, but we're going to normalize it, which would give us a length of 1, right? Normalizing it would give us a length of 1. And then we multiply that by our amount, which let's say is 10. Then we're going to get a length of 10, right? So then this is a length of 10. Let's say that's a length of 10. We're going to subtract this vector from this vector, which would basically mean that we're going to go in the opposite direction of 10, like this. So we're taking our motion that was this amount, 100, and after we subtract the 10, it's going to be the same direction, but instead it's going to be 90 instead of 100. So that's what our vector math is doing right here. And once we've done that, that bit's done. However, if the motion.length is less than our amount, then we're just going to want to be at 0 at that point. So we'll say motion equals vector 2.0, like that. Okay, now let's apply our movement. So this one's pretty easy too. First, all we have to do is do motion plus equals amount. So that's just going to add our new amount. This might be acceleration. Let's name that better. We'll name it acceleration like this. So this is our acceleration vector. Whatever it is, we'll add that to our current motion vector. And that's it. However, we do want to cap our speed to make sure that we never go faster than our max speed. So in order to do that, we can say if motion.length is greater than max speed, then motion equals motion.normalized. Remember, so we're taking our motion, but we're setting its length to 1. Then we can multiply that by our max speed. So that allows us to set our motion to the max speed. Now there's another way to do this actually, I just remembered. You could use the clamp function, I think, which is part of the vector class. So we could say motion equals motion.clamped, and then just pass in max speed like this. So that's actually a better way of doing it, because then the clamp function does the math for us, and it would be a little bit faster. So we'll just do that instead. But the other method works as well. So then we can save, come into our world, and run the game. It's going to need us to select a main scene, so we're going to select our world scene for that. And our character should be able to move around in this world. It's got really nice, smooth movement. And of course, you can play with your acceleration and max speed values in order to get different, a different feel for the movement of the game. So let's add some items that we can collide with. We'll add in a rigid body 2D, or a static body 2D, and we'll add, it needs a collider, so we'll add a new collision. Instead of doing a shape, we'll do a collision polygon. And so in order to do this, we're going to actually set snap on. So we'll come up here, we'll configure snap, we'll do 32 by 32, close. We'll turn snap on by clicking on that. You can see we get our grid now, but then we'll also click on view and show grid so we can see this area. Then when we have the collision polygon selected, you'll see these new buttons up here. And we'll click on the green one. This will allow us to add new points to the collision polygon. So I'm just going to click there, and then click here, and click here, and click here, and maybe here. And then I'm going to make some shapes here. Something like this. And then I think I can click on that and then click up here. So we've created this weird collision polygon shape for our static body. And I'll just save the game. And then in debug mode, we're going to do visible collision shapes. If I click up here, click visible collision shapes, this will allow us to see the collision shapes while we're moving around in the room. And you can see we've got nice, smooth collisions with these edges. Our character can move around in this world. So that's going to be it for this tutorial. I'm planning on doing more tutorials kind of like this, some simpler ones. I'm also working on a new course for Godot, and I'm still working on my games. once I've kind of got the course started, I'm going to be doing tutorial content and course content like support and stuff on Mondays, Tuesdays, and Wednesdays, and then going to be working on my game on Thursdays and Fridays. That's the current plan. My 2 games, actually. I've got 2 in the works right now. But so I'm excited to tell you more about the course. And if you want to follow my Twitch channel, that's usually where I stream development on my games. There will be a link in the description where you can follow my Twitch channel as well. Thank you all so much for your continued support, and I will talk to you all later.